Thanks to Assistant Molly, we have 2 beakers half full with sugar. Yay! Filling up the beakers with 40 milliliters of water. Right here we have 2 beakers of sugar. This one has concentrated sulfuric acid. This one has water. We're going to pour in the liquids and see what happens. In this beaker, with the water and the sugar, a physical reaction occurred. This means that the substance that's created still has the same properties as the sugar and the water did. We could also separate the two by evaporating the water, and we just end up with sugar crystals. In this beaker, with the concentrated sulfuric acid and sugar, a chemical reaction occurred. This means that it now has entirely new properties, unlike the concentrated sulfuric acid properties and the sugar properties. The reaction created SO2 and water vapor, which makes the charcoal mass expand and grow, and the water vapor creates the smoky gas that occurs. Here we've shown the difference between a physical and a chemical reaction. Boiling water is an example of a physical reaction, because it's still water, just in different forms. And the pasta? Cooking pasta is an example of a chemical reaction, because the pasta at first is all crunchy and hard, and then it has different properties and is soft and yummy. Yum! Pasta! Pasta! Let's see what happens when we light this ordinary piece of paper on fire.
Por ti volaré, despiértame, It's taking a really long time to end, and my breath is going out. Magic!
So what we did was we take this supersaturated solution of potassium nitrate and water and draw it on the paper. This is an example of an oxidation reaction. Oxidation reactions occur when one or more electrons are stolen. This often occurs with oxygen because they have 6 valence electrons and are constantly stealing from others to create 8. This reaction, the potassium nitrate and water is put on the paper, and the water evaporates in the air, leaving just potassium nitrate. The heat that is added when the match touches the potassium nitrate on the paper causes enough energy for the active oxygen in the potassium nitrate to be released and cause the reaction. So the fire on paper reaction was an example of an oxidation reaction. Other oxidation reactions in the real world are rust on metal, like here, or the browning of apples.
58 matches were harmed in the making of this video. Okay, first we will put this copper penny in the fire until it's red hot, which means it's exothermic, meaning it's producing heat. Now that the penny is red hot, we are going to dangle it in a jar above acetone, and we're going to turn the lights off and see if it glows.
It's glowing! Oh my god, it's working! Okay, wait, this is so cool. This is actually so cool.
So here we see that the penny is glowing. We know that it is glowing because it is a catalyst to this reaction. A catalyst means that it is not actually changing its properties during the reaction. It's just there to help speed up the process. In this reaction, it is acetone at the bottom of the jar turning into acetaldehyde. And the penny is glowing because that's the energy that we see it putting out to speed up that process. So in the glowing penny experiment, the copper penny was the catalyst. In the real world, there's a lot of catalysts. For making wine and bread, yeast is the catalyst, which speeds up the fermenting process. In conclusion,
We hope
you
enjoyed
our
experiments to
sum
it up.
we
Showed you
a
chemical versus
physical
reaction and
a
catalyst reaction
and
a oxidization
reaction. We hope to see you soon on Raybamo Trees.